heard of the glassy winged sharpshooter? Did you know it's marching across the South Pacific at the moment, and there's a real danger that it could invade Australia? So what is it? To tell us all about it, I'm joined in the studio by one of our local researchers at the Department of Primary Industries Research Station at Narara, which will soon be transferring to the Ourimbah campus, we're told. And they're very excited at the Ourimbah campus about that. Speaking to Bill Gladstone, the head of research there, the marine scientist, and he was rubbing his hands together with glee because it really dovetails in nicely with their food technology and other courses there, and hopefully some more federal money as well going to the important work that they do. Anna Rathi joins us, along with Lee Pilkington, who had us fascinated with his videos of these critters that he uses in biological control at the Narara Research Centre in Greenhouse and Horticulture Research. Good to have you both in the studio.
Thanks, Scott. Thank you for having us.
And good to have you back, Lee.
Yeah, thanks very much for having me back.
And thanks for bringing photos of what this... It's quite a beautiful little insect, actually, isn't it?
It is pretty nice. I mean, people ask why we do stuff like entomology, and then you always pull out the nice glamour shots like this. It's a nice big insect. It's about 5 to 10 millimetres long, so it's quite big, yeah. You can grab it in your hands and move it around, quite tame, make it do what you want it to do.
It's almost... like, I'm trying to describe it, maybe a tiny cicada?
Yeah, it's distantly related to cicadas, so you can sort of see that similar shape across the head, the eyes on the side there, nice big bulbous eyes.
Big bulbous nose, a bit like a Black Prince or one of those ones.
Yeah.
I don't know what the real names are, but, you know, we used
they'll be good enough.
Collect them as kids.
Throw them at the girls, yeah, we used to.
I know the pissy whackers we used to do that with. The ones that, you know, used to shoot out some sort of liquid when you squeeze them. Oh, you're a naughty boy. Anyway, so this is a pest insect, and where's it originally from?
The insect is originally from the Americas, so southern America and Mexico.
You would think that, and it's been causing havoc in California?
Yeah, specifically California. It's also spread to some of the Pacific Islands, Hawaii. It's a big problem in French Polynesia, particularly Tahiti. It's recently been discovered in the Cook Islands as well, so it's definitely making its way towards Australia.
What does it eat?
What does it eat? Well, it actually eats a substance called xylem fluid, which is basically it's the fluid contained in the water transport vessels in a plant, so it's really nutrient poor, so it has to basically suck up this liquid really rapidly and quite constantly.
So sort of a leaf sap, basically.
Yeah, you could say that.
So it's a leaf sap sucker.
Yes.
All right, and what does that do to the plant that it's feeding on?
Well, the feeding activity itself is not too much of a problem. Obviously, the plant would rather have the substance in it to use, but the feeding's not such a problem. It's more the disease that the insect carries with it that is a problem in terms of the plant survival.
Right. And what's your area of research, Anna? Because I know that Lee is right into the biological control side of things and finding Australian insects that can't go feral, that do the biological control job. What's your area of research?
Well, my background is quite broad, just environmental science as a whole. I suppose more specifically plant pathology, biosecurity, and recently the entomology field. Right.
And Lee, this little critter, what are some of the strategies that you're working on to halt its march?
Well, what we're looking at, because it's so good at moving across the South Pacific, because it's a big, sturdy insect. You've got a picture of the egg mass there in front of you on a leaf, which is quite cryptic, so you can sneak it in on plants without really sort of knowing, unless you know exactly what you're looking for.
So no plants. We shouldn't be bringing any plants in.
Oh, we can bring plants in, but we have a lot of procedures in place to stop it. So when you're bringing plants like grape material into Australia, what we do is Aquis take care of things by having them with cold storage at between 1 and 4 degrees for an extended period of time, and that kills the pathogen that causes the disease off, but it will also affect the insect as well. So whilst the insects are a little bit cryptic in the egg stage, the adults, you can spot them fairly easily, so you can sort of control it that way.
And what sort of disease is it? Is it a fungal disease or is it a...
It's a bacterial disease. It causes a number of different diseases. The pathogen causes Pierce's disease in grapevines, which is the important one because that's going to affect our viticulture industry, obviously. But in the States, I mean, you've got a lot of other diseases that it causes in almonds, even obscure things like oleander plantings along the freeway plantings in California. It's caused about $32 million worth of damage just to replace those ornamental plants.
Geez, it must be bad if it can kill oleander. It's the toughest thing known to man.
Couldn't kill it with a stick, but this guy does it, doesn't it?
You go out west and see where the old homesteads were, and they had borders of oleander, and they're quite poisonous, aren't they, oleander?
Yeah. So these guys, they're great vectors because they suck so much. Anna was saying that it's a nutrient-poor stuff that they suck on. So the xylem, it just goes through them. The equivalent rate of feeding is about 10 metres per second. So, I mean, you're only talking about a tiny little drop, but they're pulling it through so quick. So it's coming in one end and it's going out the other end just as quick.
Right.
So in Tahiti, they actually have a common name for it, if I may be a little bit crass. It's called the pissing fly because it just rains out of the trees and the fluid will run down the road and run off cars.
And the disease is in that. It's in the gut of the animal, is it?
The disease is actually in the stylet, in the mouth parts of the insect. So it's kind of like when you shake hands with someone with a cold, you're just transferring it mechanically like that.
Yeah. And this disease we haven't seen, Anna? It hasn't been in Australia?
Not to date, not that we know of. There have been past surveys searching for it, which haven't come up with anything, but I intend to undertake some more surveys of known host plants to see if we can detect it here, but we're hoping it's not here yet.
And do we know what this glassy-winged sharpshooter will eat when it gets here? Because saying that it hits the grape industry and likes those vines, what about our natives? Do we know if it'll get into our natives?
Well, no, we don't yet. There have been a few records in California of the insect feeding on eucalyptus, but other than that, it's a bit of a mystery how it will interact with our native species. So that's what I hope to find out about. So when it gets to Australia, we know that it will feed on citrus and grape and all these sort of things, but maybe our native species will provide a reservoir of the pathogen from which the insect can then spread it to all of our important crops.
That's a bad scenario. That's a bad scenario.
It is. So we hope to find out how it will interact with our native plant species so that we can take quick action to stop it from spreading once it arrives.
Is it a prolific breeder?
The insect, in California it has sort of 2 to 3 generations a year, but in Tahiti, its invaded range, it can be up to 6 to 8 generations.
Because of the tropical heat?
Exactly, yeah.
Wow.
So the exciting thing, Scott, here is that we can't find that information here because we can't bring the insect into Australia.
No, it's very important that you go over. It's very important. We see all of these junkets that some go on, but this is really vital work. You've got to go and do this research.
Yeah, vital and exciting. So it's just something that we can bring back with a lot of information, and that's in a week and a half's time. This time next week we'll be getting ready to go over. And
will there be a lot of collaboration with other agricultural scientists? You'll be hooking up with some of the people who are obviously trying to fight this spread?
Yeah, absolutely. There are a lot of people in the United States working on the whole pathosystem. And so I'll be obviously tapping into their knowledge and using some of their methods to try and determine how it's going to operate when it gets to Australia.
And what about seeking out biological warriors to stop the glassy-winged sharpshooter, Lee? That's your baby, isn't it?
Yeah, I guess it's something that we'll look at later on. I was doing that work in California when I was there a couple of years ago doing some postdoc research.
How are they going with that? Are they getting some results?
Yeah, it's going pretty well. They've started to scale down and they're getting it under control a little bit over there. When I was there were 72 funded research programs on the glassy-winged sharpshooter, and now they've scaled that down to sort of 6 or 7.
What have you found? A wasp, a beetle,
well, they use a wasp over there,
parasite? What have you found?
Yeah, a tiny little parasitoid wasp that lays an egg inside the egg of the glassy-winged sharpshooter.
Great.
It's kind of like something out of Aliens,
Only in the glassy-winged sharpshooter?
Yeah, that particular species there does. We have some of the similar species here, so what our challenge will be is to understand where the glassy-wing will be here when it comes in Australia, and then look for a native equivalent to what they've got in the States. And so we use natives, as we discussed last time, just to help eliminate the chance of it spreading over onto a species we don't want it to control.
Yeah. Although the cactoblastis moth It did all right, didn't it?
Yeah,
it didn't go feral.
Yeah, there's lots of success stories. We always focus on the negatives, but that's a great positive to think about.
Yeah. See, I didn't talk about the cane toad at all.
Yeah. Oh, there it goes.
Oh, well, good luck with it. What are some of the biological controls other than the wasp? Are there any others that are being, or you know, your work when you come back will be to find native wasps to fill the role that this Californian wasp is filling?
Yeah, that's right. There are some generalist predators that actually eat the eggs, but they're not quite as effective. The parasitoids by far are and above the best parasitoid, the best control agents.
Yeah. And how can we be vigilant as gardeners or vegetable shoppers or whatever to make sure we don't get this stuff?
Well, there's a lot of campaigns that go around telling people about keeping an eye out for things. You know, when you go into the fruit fly exclusion zone or you go into phylloxera areas, we just ask people to keep an eye out in their gardens. If they do see something that looks a little strange and something they haven't seen before, that they just contact either AQUIS or the Department of Industry and Investment, which we're a part of now, the Department of Primary Industries.
Yeah.
And we can just get someone to check it out. Sometimes it's nothing.
Do you think you'll be able to stop it, guys?
Well, we're certainly having to be ready for it if it does arrive, and that's the main thing, so we know where it's going to be and how to go after it.
Absolutely. There's no control for the disease, for the bacteria itself. So the main thing is to understand how the insect's going to function, and so we can work at managing that.
What are the ramifications of the disease if this glassy winged sharpshooter does its eating and weeing trick and fills the plant full of it? What happens to the plant?
Well, basically, once the bacteria is inside the plant, it will build up a population, and that can actually block the movement of the fluid, which basically causes water stress to the plant. So you get leaf yellowing and necrosis, and plants are just generally not very happy. This can either kill them or they can just live with the symptoms. And it's really bad for citrus, grape industry, whole range of industries.
There's
really.
no treatment that you can give?
Nope.
Once it's got it, that's it.
Cut out your vines, destroy them all, burn them.
That's pretty drastic, isn't it?
Yeah.
All right, well, good luck with the research trip. Thank you very much for telling us about it. Lee Pilkington there, and Dr. Lee, and also there are a PhD student, Anna Rathi, who is heading off as well to get into some great research to hopefully stop this glassy winged sharpshooter from bringing its disease to Australia. Thanks for your time.
Thank you for having us.
Thanks for having us, Scott. Cheers.
92.5 ABC Central Coast is 24 to 12. We'll check some news headlines with Brad Story in